Okay, so let's try the next coding exercise. So open the leetcode.com and click on the problem section. And if you scroll down in the search tab, search merge sorted list and hit enter. There is a problem number like 21. Merge two sorted list and it's come under the easy category, and actually an easy category if we know a little concept, like it's under the easy category. So click on it. So the even the question says like merge two sorted list, but the question is for the linked list. Right. So what is mentioned? You are given the head. So the heads are given. So list one and list two are the heads. Heads of the two sorted linked list. So two sorted linked lists are given, and so these are the sorted. So 1, 2, 4, 1, 3, 4. Merge the two lists in a one sorted list. So we need to merge, and that we need to merge these two lists, and the output should also be the sorted one. The list should be made by splicing together nodes of the list first two list. Return the head of the merged linked list. So like when we merge the list, we can return its head. So let's understand first like what is linked list. So so generally, like what is list? So list is just like a combination of you can say a number of elements like one, two, three, 4, 5. So this is a list. All right. So what is the difference between list and the linked list? So in the linked list, the concept is like almost same, but so there is a one block this one block this, one block this. Right. So like this is also a list like this is a continuation, but this is not a continuation. This is kind of a like these are also like linked with each other, but using some pointers. And there are some nodes. So one node is this, second node is this, third node is this, and even the one node consists of two part. One is the value, and one is the next pointer. So similarly, one is the value, and other is the next pointer. So one is the value, other is the next pointer. Right. As an example, so let's suppose this list contains one as a value and the next pointer contains. So let's suppose how to do the arrow symbol. I don't know. Chart function. Okay, anyhow, so there is an arrow. So next means like there is an arrow, and this arrow is pointing. So this arrow is pointing to this value, to this value. So here, let's suppose the value is 3, and there is also some arrow. So this arrow, so this arrow is pointing to this value. Okay, so let's put this 4. And now there is one more arrow, but our elements has been ended. So it is pointing to the none. So last element should be none. And the first element is the head. So we can say it's head, it's head. So this is the linked list. So that's why even if you see the code now, in the code it is mentioned, and even the diagram, like you could see there are some arrow, because when the generally the list is given, when the question is of list, so even in the example in the diagram you could see some kind of this diagram, the one which I just highlighted. And when you see the concept of the linked list, you could see this kind of diagram where you could see some bubbles and there are some pointers. All right. And there is a one node. So one node, this is a one node where I am moving my cursor. This is a one node. This is the second node. This is the third node. So one node consists of two parts. One is the data, that is the value, and the other is the next pointer. All right. So they have given the list node. There is a list node class. So how they are creating this node? So there is a list node class. If we are calling the list node class, so automatically within a one node there are two values. There are two things, like the node consists of two things. One is value and one is next pointer. That's why they are passing value and as well the next pointer. So next pointer by default is a none, because if there is just one node, if we have to define only one node, all right. So here is a value and here is a next pointer. So value by default is 0 and the next pointer could be none. All right. So the same thing like they have mentioned one class, and in the one class they have mentioned value and they have mentioned the next pointer. So and self dot value is equal to value, self dot next is equal to next. So they have defined how they are, and this is the singly linked list. So there is only a pointer in a single direction. All right. So we need to merge these list, these and both are list are the sorted list, and we need to merge. So as an example, so we have seen this example. And if both the lists are empty, the output should be empty. If one is list empty and output the list two is zero, so the output is zero. And we have to sort in the non-decreasing order. All right. So how to do that? So we know we have two pointers given. One is, and there are two pointers, list one pointer and the list two pointer. So list one is the head. So basically in this class, there is a one function merge two list. In the merge two list, there is a list one and there is a list two. So the list one is the pointer itself, because they have mentioned you have given the heads of two sorted linked list. Because to traverse the linked list, we need one pointer, and that pointer already given. So list one is the pointer which is pointing to the node one of the list one. So list two is the pointer which is pointing to the node one of the list two. So head pointers are given. All right. So how we are going to so there are two pointers. As an example, let me show you. So, okay. So these are the these are the question we have to do this. So right now both the pointers are pointing on the node one. Now we need to sort it, and by sorting we need to generate one list. So if we generate a one list, so we need at least one output list, like, because whenever we want to store the output, we need some variable, right? So we need some list, like, because when we are merging two lists, so we need the third list as well, like. So similarly, when we are merging two linked lists, so we need the third linked list as well, right, as an output list, right? So let's define that third output list. So how you are defining the linked list? Because the list generally you define like this, all right? But this is a list. This is not a linked list. So how you are defining the linked list? So in the linked list, they have mentioned the class list node. So you have to just define this class list node. That's it. So now this output is a linked list, and that linked list contains only an like empty value. Like, this is just only one node. That linked list contains only one node, and that node has value 0 and the next pointer is none. All right. So because we need one output in which we are going to store. Okay. Now we have two pointers, one pointer on the node one pointer on the node one of the list one and the list two. So how you are going to know which one we have to put first? All right, because we have to compare. So we need to traverse the list one, we need to traverse the list two. But it is not mandatory that the both the lists are of the same size. So maybe list one has only one element and list two has 1,000 elements, right? So we need to traverse both the list till list did not end. So we need to traverse both the list till list did not. So while list one and list two. So while while list one and the list two. So now we are running some loop till like 1 to 4, or till like list 1 did not end, and similarly till list 2 did not end. All right. So we are running some loop, and so right now the pointer is on the first node. So first we will compare the value. We will compare the value of both the pointers. So if we have to compare the pointer, if list 1 dot value, if list 1 is pointing to the current node, so if current node value is less than or equal to list 2 dot value. Okay, so if like whoever is the the smaller, so as an example, so let me do this like one two, so let's suppose this is the two. All right, so one two, so uh, our pointer is here. So one two, so first I have to compare one with two. So which is smallest or which is equal, because they can be equal or they can be smallest. Whoever is the smallest, I need to store that element in my output, because I found, because otherwise my pointer will go to the next condition, like the next as an example. So I have this list 1 2 4. I have second list 1 3 4. Right now my pointer is on this right now my pointer, both the pointers pointing to the first element, list one and the list two. These are the head element. So first I will compare list one with the list two, whichever is the less. Whichever is the less, I have taken the output variable. So whichever is the less, so I am going to point. So whichever is the less, so let's suppose Control C. So whichever is the lesser, I am going to point is next pointer to that element, to that element. All right. So if list one dot value is less than equal to list two dot value, what I have to do is, so output we need to store in the output. So how we are going to store? So output, sorry, Control Z. We have to type it. So output dot next is equal to list one. So our output variable, this is the output. So our output dot next, because first element is 0, which is fine. Output dot next. So output dot next, we have to point to the one means the list one. Earlier the one is the list one, so we have to point to this because one is the smallest one. And we have to move list to the next pointer, because one is done. Now we have to move list to the next pointer, because now list one is equal to list one dot next. So my head is my head is pointing to this element. Now my head is pointing to this element. Now I am going to compare two with one, because like we compare one with one, and there's a condition less than equal to. So less than equal to. So less than equal to means like we are picking the first element like of the list one. So list one pick, one is done. Now second pointer did not move because we moved only first pointer. So that's why we move because this element is completed. So now we have to go to the next pointer. So how you are going to the next pointer? List one is equal to list one dot next. So because how you are going to the next pointer using the next operation. So now you have to put head into the, and what is the next element? Next element is list one, because right now list one is this. So next element is, so what is this? This is list one dot next. So what I did is list one dot next will become, this is list one dot next. This is list one dot next dot next. So I make this element as a list one. So the same thing I did. List one is equal to list one dot next. Else, if list one is not smaller, like if one is not smaller, this one is smaller. Like there should be some five element. There should be some value five. There should be some two. Then we are storing, we are pointing our output node to list two, and we are increasing our list two pointer, and we will not going to move our list one pointer. So if this is smaller, then we are going to, the list one will remain here and list two will move to this point, this place. Okay. So now this is done. Okay. So what next? So it will like continue. But if you see here, if it will leave continue, we will not move to the output pointer, because earlier output dot next is pointing to the list one. Now our list one is here. here, and whatever the element will come. So if we just write this code, what will happen? So we are list one pointer is on the node one, list two pointers on this node. So we will compare first two elements. So first element is less, right? So we are there is some output element. So we are output dot next because we take some empty node. So we take some empty node. So output dot next is pointing to the list one. So right now it is pointing to the list one. All right. Okay. So list one. If like let's suppose like list one is smaller, then output is pointing to the then output might point to the list two, like whatever. Like that is just a else condition. So let's suppose it will point on into the list one only, right? So list one. So which is one. So now list one move forward. Now list one move forward. Here it is two. It is it is here like it is pointing. It is pointing, right? So it is pointing. So now list one moved forward. Okay. Now we are again checking list one dot list two. Then we are checking. Then what we are doing is we are doing the same thing only. So output is this only. Output is this. So we have to move this output as well, because if we are again looping the same thing only, now our pointer is list one is pointer is on two, list two is pointer is on the one. Now we are comparing both the elements. Now we found okay, one is left and one is left, which is in the list two. Now we are saying output dot next pointing to the list two. But output dot next is pointing to the one, right? So one is done. Now we have to make output to this element, output to this element, so that output dot next will become to this element. So that now one will going to point to this one. So that's why we have to write here output is equal to output dot next. Okay. So now like it will traverse all the list. But there is a one condition. Let's suppose if list one is larger and list two is less. And we are taking the condition by list one and the list two. So list one finished. List one is lengthy, list two is finished. So we will check if list one, if list one is there. As an example, let me give you one example. So let's suppose list one is one, two, three, four, five, and list two is just uh, two. All right. So we starting from both the pointers. So one, two. We will compare one and two. Okay, one is there. Okay. Now one is there. Now we one is there. So we are moving to this pointer. So earlier both the pointers are here. So let me paste that point here. So earlier both the points are here. All right. So first we compare one and two. Okay, out in the output we store one. Now we move to the next pointer because list one stored. So now we will not moving the list two pointer. We move the sorry, we are moving the list one pointer. So now list one pointer is pointing to two. So now we compare two. So let's suppose two again come. All right, from the first one only, from the list one. Now we are pointing to the, we again like move this pointer forward. All right, so now we are pointing three and two. So out of three and two, two is shortest. So now two will come. Now we have to increase our list two pointer. So list one pointer is here on three, but we have to increase our list two pointer. So list two pointer end. So our loop end. So if our list two loop end, so how we are going to put this element into the array? Because we need this element here as well. 3, 4, 5. I need this element here as well. But loop going to finish. How I am going to compare? So that's why I am comparing only till that part until list one and list two did not finish. So once list two finish, I am checking if list one is still there. If list one is not none, if list one is still there, what I will do is output dot next is equal to list one. That's it. Whatever the all the remaining pointer, it will point to the last element of the output. If list two, then output dot next is equal to list two. All right. And so this is the output. Now I have to return the head, but our output is because we are we are progressing further. So right now output is this. So now output will become this. Then output will become sorry. First output is this. One second. First output is this. Then output will become this. Control X. Then output will become this. Then output will become this. Then output will become this like sorry. Then output will become eh? Then output will become this. Then output will become this. So at the last, our output is as pointing to 4. But we need the one pointer. How we are going to print? Because if we are going to print, only 4 is going to print. But we need 1, 1, 2, 3, 4, 4. We have to print. So we need the first pointer itself. So what we are doing, so what we will do within the starting as well, we are going to store the head pointer. So there are two, we are going to store the head pointer. So current is not moving, only output is moving. We are before proceeding further, the output element we are storing it, and then we are returning when the while loop will finish. We will return current dot next. Why we have not returned the current? So if you are just returning current, it is going to fail. Let me show you. So see, we are expecting 1 1 2 3 4 4, but we are getting 0 1 1 2 3 4 4. Why we are getting 0? Because you remember we took the output node as first is 0 next, and then we are pointing 1 2 3 4. So basically we have to start from this is the current element. This is the current. If I am just printing current, then it will print 0 as well. If I print current dot next, then it will start from here. It will start from here. If I print current dot next, so it will start from here. So that's why I am printing current dot next. Let's run it. So run. So let's submit it. Yeah. So all the test cases has been passed. So that this is not very easy question. We have to just know how you have to move, like what is head pointer, how the linked list design. So linked list has two element value and the next. How you have to move to the next pointer, like list one is equal to list one dot next. That's it. And how you will get the value of the data. So value of the data will be using the value variable, list one dot value, list two dot value. We are doing nothing. We are just looping parallelly on both the linked list, and we are comparing the value. Whatever is the value, we have to store into the third linked list, and we know how to define the linked list because this is not a list. So that is defined using some class. So we have defined some list node, that is empty node. Then we are like just storing that element into that. And because the list one can be big and list two can be smaller, or list two can be big, list one can be smaller, then we are checking if list one still left, then whatever the remaining element of the list one, we are pointing the last element of the output, whatever the output generated till here. If list 2 is large and list 2 still left, whatever the output element remaining of the list 2, we are pointing to the output of the last element of our output. And we are storing the current element because we have to always return using the head pointer, not the last pointer. So that's why we store the head pointer here. Current is equal to output. So if we just return current, because if we can't return current, because if we just return current, then it is going to print 0 because by default value is 0. So first node is 0. That's why we are starting from the current dot next. So this is the easy question, and you come on the linked list category. So maybe we will do further more question on the linked list. So yeah, you can also try. That's it. That's the end of the video. Thank you.